Hi guys, Omores here. Today it's about CSMWrap, a very neat project by FlyGoat and Mintsuki, and probably the next big thing in retrocomputing. Why? Because CSMWrap is basically a bootloader with a complete x86 BIOS built right inside it that lets us run a legacy BIOS environment while staying in UEFI mode. And the way it does this is actually really clever. Everything is crammed into a single tiny FE file, which we can drop it on some drive. Our UEFI firmware picks it up, and from that point it takes over without changing anything on our actual firmware. In this video I'll show you how to set it up, which is no big deal at all, and we'll test it with a few OSes like Windows XP, x64, Windows Vista, and of course Windows 98. As the name implies, CSMWrap is related to CSM, which on modern BIOSes stands for Compatibility Support Module. It's the thing that provides classic PC BIOS services so we can run older hardware on UEFI motherboards, like an older graphics card with a VGA BIOS. It's also the magic that lets us run older operating systems on modern hardware, which is kind of what this channel is all about. If you're new here, here is a very quick rundown of older operating systems having a great time on modern hardware. Here is Windows 95 booting on a Ryzen 9 9900X PC, but we can go even further back than 1995. Here is DOS 3.3 from 1987 doing the same thing. And here it is, of course, the star of the channel, Windows 98. But that's not all. Here is Windows NT 4 from 1996 running with NVMe support. Windows 2000 runs great too, and the list goes on. Oh, and let's not forget Windows 3.1, this time on an Intel Socket 1700 build, running with full HD support on real hardware thanks to a newly released VBE driver. So what is CSMWrap exactly? Well, it's essentially the same thing as standard CSM. Its purpose is to recreate a complete legacy BIOS environment. It does this by wrapping a SeaBIOS, which is a well-known open-source BIOS implementation. I talked about SeaBIOS before when I showed you this crazy 3DFX Voodoo custom MXM card from sdzmods.com. Back then, SeaBIOS was used to boot with a Voodoo 4 card as the primary adapter on a Dell laptop, which wouldn't normally allow this through its own firmware. By the way, with CSMWrap and SeaBIOS I briefly booted the 1998 x86 version of Rhapsody OS from Apple on my Ryzen 9 PC, and everything looked fine, lots of PCI devices listed and all. It almost felt like SeaBIOS was optimized for it, but I'm pretty sure no one cares about Rhapsody OS. It's just a very by-the-book BIOS implementation, except there is no SATA to IDE emulation, so I couldn't go any further. Anyway, IDE support is something that could be added later, and that's exactly what makes a project like CSMWrap so valuable. It can be customized and expanded, and more importantly, sooner or later it will be probably the only option, as every new motherboard will run in UEFI mode only. CSM is already gone on LGA 1851, but it's still going strong on M5, the hottest platform as we speak. And you know what else is in demand right now? Backend development. Now real quick, I want to talk about today's sponsor, Boot.dev. So if you ever try to learn coding and just lost interest somewhere between Hello World and your third hour of lecture slides, Boot.dev is built for exactly that problem, because learning can actually be fun. Just watch this random short clip.
And the best tool for moving digital garbage is SQL, or SQL, or Squeal.
Squeal.
So say you're a programmer at Google working on YouTube. Your job...
Not every single lesson is like that, but that's the general vibe on Boot.dev. There is this dry, self-aware humor running through a lot of it. On top of that, the platform is built like an RPG. You're earning XP, leveling up, completing quests, fighting bosses while learning Python, Go, SQL, TypeScript, JavaScript. You know, the stuff companies actually pay for. Backend developers in the US make over 100K on average. And if that's your goal, Boot.dev is built to take you there without falling asleep. There is also an AI tutor called Boot, a bear wizard, helpful and slightly annoying in the best way possible. He asks you questions until you figure it out rather than just handing you the answer. Also, all the videos and reading are completely free. You only pay if you want the interactive coding environment, the XP, the progress tracking, all those extras. Plus, there is a 30-day money-back guarantee if it's not for you. But you can't know until you try it, so go to Boot.dev and use my code Omores2 for 25% off your first year. Links in the description, or just use that big QR code on the screen. Alright, there is also the case where CSMWrap comes in handy when the motherboard fully supports CSM, but the option is disabled. The main reason being when our GPU doesn't have a VGA BIOS. And this is actually the case with all latest generation iGPUs. They can work only in UEFI mode. With discrete cards, it's mostly the opposite story, at least with NVIDIA, which holds over 90% of the market. All the modern GPUs, including the latest RTX 5000 series, still include a VGA BIOS alongside a UEFI BIOS. Here is an RTX 5060 Ti running VGA benchmarks in DOS. We can even play some DOS games, although the VGA BIOS isn't as compatible as it used to be. I'm happy it's still there, and it's definitely better than no support at all, as is the case with the latest AMD and Intel discrete GPUs. Alright, now let's see how can we run CSMWrap. First, we need to make sure a few things are disabled in the BIOS. Let's start with Secure Boot. A classic PC BIOS uses the master boot record, or MBR, to start the boot process. The BIOS simply executes whatever it finds in sector 0 of the bootable drive, no questions asked. UEFI works differently. Instead of using the MBR, the firmware looks for the FE system partition, or ESP, and loads the file boot x64 FE from the boot folder. If Secure Boot is enabled, that FE file also has to be digitally signed. CSMWrap isn't signed, so Secure Boot needs to be disabled, unless we want to manually sign the file. Next, we need to download CSMWrap x64 file and rename it to boot x64 FE. There is also a 32-bit version for systems with 32-bit UEFI firmware, mostly older Intel Atom machines. We don't need that. For regular desktop motherboards, what we need is CSMWrap x64 FE, which works with both 32-bit and 64-bit operating systems. Once we have the file, we need to place it on a small FAT or FAT32 partition on a GPT formatted drive. Ideally, the partition should be around 100 to 500 megabytes, since some early UEFI implementation can have issues with larger partitions, so keeping it small is usually safer. And that's pretty much all we need to do to boot with CSMWrap. Now, booting is one thing, but to make it sure it actually works, we also need to disable above 4G decoding and a PCIe resizable bar in the BIOS. On paper, CSMWrap should run fine in a pure UEFI environment with the native CSM disabled, and that's actually the recommended setup, since both can conflict when managing legacy resources. But if CSMWrap gets stuck, we have to enable the native CSM, since some hardware still depends on it for low-level initialization that CSMWrap doesn't handle. On my Ryzen 9 system, I first tried running it with CSM disabled, but it didn't work. CSMWrap would simply freeze. I didn't dig much deeper into it, so I enabled the onboard CSM, and after that CSMWrap started normally and SeaBIOS successfully initialized the hardware. We're talking about AHCI, USB 3, NVMe drives, and so on. Everything was detected correctly, including my SSD with Windows NT and Windows 95. These OSes don't work with the onboard SATA on my Ryzen 9 PC, and well, it didn't work through CSMWrap and SeaBIOS either. I was actually expecting that because the legacy AHCI implementation in SeaBIOS doesn't work with Windows 9X anyway. I know this because I tried before. Next, I tried to boot Windows 98 from NVMe, since this works perfectly fine on my Ryzen 9 system with the regular CSM. So yeah, I'm happy to report that Windows 98 works with CSMWrap. What I couldn't do was install the video drivers. Might be this particular NVIDIA drivers, but most likely it's related to CSMWrap. I could initialize the card with VBA drivers from Windows 3.1 though. So I think eventually Windows 98 will fully work, because one of the guys in charge of this project also created crackfix, which allows Windows 98 to be installed on modern hardware in the first place. Yes, we're talking about Mintsuki, so Windows 98 support is in very good hands. Next, I move on to Windows XP, which is one OS I'm sure many people want to see it running on a UEFI system. XP is officially listed as tested and working with CSMWrap, although there are some known video card issues on certain configurations. In my case though, with an NVIDIA 7900GS it worked perfectly. So yes, it simply works. If you want to see how to install it, check out this older video of mine. It actually turned to be quite popular. Now, to finish things with some style, we'll also take a look at Windows Vista x64, which works fine with the regular CSM on my Ryzen 9 9900X build. One interesting detail is that devices don't need to be reconfigured when switching between the two, since both CSMWrap and the built-in CSM use the same AHCI tables provided by the UEFI firmware. What you're seeing now on the screen is Vista reconfiguring itself on this Ryzen 9 system, since this build was originally installed on an Intel PC. Now you might wonder, since on this configuration CSM needs to be enabled, is CSMWrap actually doing something? Well, it's definitely in charge, and that's pretty easy to check, because CSMWrap reserves one CPU core for system use, along with a tiny amount of RAM. So with CSMWrap on this Ryzen 9 configuration, we'll have 23 CPUs instead of 24. Now I guess you're curious about the performance impact, so I ran a 3D Mark 2001 on both, and the results were basically the same, well, within the margin of error. With the native CSM, we got 50.3k points, and with CSMWrap, just 50.4k points. Near native performance is the goal of this project, and at least with this benchmark, that's totally the case. Now, you might also ask, what's the point of running a custom CSM module on top of an existing one? If the onboard CSM works well, then yes, we should probably just use it. But the main target for CSMWrap is systems that no longer have CSM support at all. Also, the big advantage is that CSMWrap can keep improving over time. For example, starting with version 3.0, tested today, a new feature was added, and this is a feature I'm particularly interested in: the ability to choose which video card is used as primary adapter, something most motherboard CSM implementations simply don't allow. I'll definitely cover that in a future video, so stay tuned. That's it for today. Many thanks to Boot.dev for sponsoring. Make sure to check them out using the QR code on the screen. Omores out.